This video shows the autonomous object interaction behavior used for object learning for the bottles applied to something that's not a bottle, a tapered shaped blue cup with a very different height and very different width. So the robot at this point is asking for user permission to nudge the object, and as you can see on screen there, the object location is visualized as a workspace visualization. The camera is shown as the red box. The object is shown as a blue circle with a dot in the middle. The green arrow is where the robot would like to nudge the object, so the direction and the distance of the nudge to be performed. And the idea with this sequence is that a lot of pauses and user requests have been added to the learning so that the user can give it the go-ahead, and also to allow videoing of the visualization. And you can also notice that the scene here is very yellow compared to the white bottle video, and that's because there's a lot of sunlight coming in, but the vision system is robust enough to handle lighting changes like that. So now I'm giving the robot a go-ahead to perform the nudge. So the object has been nudged successfully, and the motion generated is used to perform object segmentation. And normally tracking is performed in parallel with the nudge, so you can't see it because I can't show both at the same time with the HDV camera. But what I've done here, and why there is a pause, is because I've taken the tracking offline so that it can be visualized. So you can see right there that the left camera tracking result has been visualized on screen. And as I said earlier, a lot of pauses have been added so that I can step through the different stages of object learning. So the next thing to show would be the object segmentation result. The right camera segmentation result shown there. The green line is the posterior estimate of the tracker, so the tracking result on the very final frame of tracking. And the blue dot is the top of the object segmentation along the symmetry line. And the next thing to show that will be shown is the left object segmentation. So there again, same thing. Green line is the posterior estimate of the tracker, and the blue dot is the top of this object segmentation. And those two blue dots you saw, the top of the two object segmentations from the left and right camera, are used by the robot automatically to determine the height of the object. And so the next thing is basically the robot asking me on screen whether it should be allowed to grasp the object, and I tell it yes. And so you can see now the robot's proceeding with the grasp. So again, it moves above the object and lowers the gripper. And notice that the height of the gripper is different to the height that would be needed for the bottle. So the robot has basically adapted to the height of the blue cup automatically, and has grasped it very firmly and successfully. This video skips over the object rotation and simply replaces the object. But you can see from this video that the same object interaction strategy used for learning the SIF models of the bottle can be applied to other objects that are symmetric, in this case a blue cup. And the blue cup has a very different height, probably 5 or 6 centimeters difference than the bottles, and also has a very different top width, many centimeters difference in radius than the bottle caps at the top of the bottle. So the idea is the same object learning behavior is robust and adaptable enough to deal with these different kinds of symmetric objects very reliably.